Capture of CO2 is one of several solutions, and we normally call it a toolkit. You need CO2 capture, you need renewables, you need energy efficiency, and also nuclear could play a part in combating climate change. So that's how we see it. However, to bridge the gap between fossil fuels and renewables is very important with CCS, because CCS is something we know today, a solution we could implement quite soon, in fact, while renewables will have to develop over time. Now the idea is as such ideal, but that's not how it is, I think, because as I said, one of the tools is in fact energy efficiency, reducing use of energy and so on, but it is not sufficient. The population in the world is growing. There are big differences in welfare between the rich countries and the poor countries, and the way of closing that gap is partly through increased use of energy. And there today we just have the fossil fuels. So we can't say that reducing energy is the only way. Energy efficiency is one of the tools. The history of Sleipner is quite special, in fact. Norway was, as far as I know, the first country in the world to introduce a CO2 emission tax. And the tax was at what is today roughly 40 euro per ton of CO2 emitted. Sleipner had a challenge. The CO2 content in the Sleipner gas was approximately 9%, while the gas sales agreements entered into with European buyers prescribed an upper limit of 2.5% CO2. So what the partners in the Sleipner license had to do was to remove or capture part of the CO2 to reduce the content down to 2.5. And what should you then do with the remaining 6.5% you had to emit or had to capture? You could emit them. That would be the easy solution. But partly due to the fact that there was a cost attached to it through the Norwegian CO2 tax, and partly due to environmental concerns, the partnership did go for a solution with injection. The partnership at that point in time also consists in fact of the French company ELF, together with Esso, as it was called at that time, and Statoil, now Statoil Hydro. Roughly 60% of man-made CO2 emissions are in fact coming from quite a few sources, from 6,000–7,000 huge point sources, and most of those sources could in fact be equipped with CO2 capture technology or capture facilities. So there should be a possibility, but it is costly, and currently the cost of capture in fact is roughly 80% of the cost of the full value chain, if you include capture, transportation and storage. Of course, depending on volume, on distance from source to storage and so on and so on. But between 60 and 80% is in fact capture. And we do even have today sources where the CO2 is captured. So we have already taken the 60 or 80% of the cost due to necessity in the industrial world. For instance, Sleipner, you had to reduce CO2 content. At the Snøhvit field in the Barents Sea, we are producing LNG. There we have to reduce the CO2 content even further down to 25 ppm to avoid stopping the full process. So there we have the CO2 ready for injection, and that is the same for other LNG facilities, for instance. Also have some industrial processes where the CO2 is captured but just emitted today. So if there are incentives to store the CO2 instead of emitting it, definitely is a possibility here. And storage sites you could find more or less all over the world, both onshore and offshore. According to international agencies, you have storage potential in saline aquifers of roughly 1,000 gigatons. So that should be sufficient for an early period here. But we haven't really done a full mapping of the storage sites just because there hasn't been a need for it. As of today, the 4 large storage projects in the world are Sleipner, injecting roughly 1 ton of CO2 per year. It is in Salah in Algeria, where also Statoil Hydro is a partner, injecting, or the capacity to inject up to 1.2 million a year. You have Snøhvit in the Barents Sea, operated by Statoil Hydro, where the annual injection is 0.7 million tons. And you also have Weyburn in Canada, where in fact the CO2 is injected and used for EOR purposes. So these are the 4 large or huge ones in the world as of today, and they are comprising just below, in fact, 4 million tons a year, which is not very much.
For now?
For now, yes. That is also something authorities are working on now, and that is to make it possible to have such a trans-boundary trade of CO2. CO2 could be transported either by pipeline, just like gas or oil for that sake, and by vessels. If you're talking about huge volumes over a long period of time, pipeline will be the solution. And then you have a cost issue if it should be pipeline or vessel if it is short time, small volumes. Indeed, we do think that for CCS, carbon capture and storage, to become a vital tool in combating climate change, it needs to be commercial. Companies need incentives for doing this. If not, they'll just drag their feet and will not reach the ambitions, political ambitions set in quite a lot of countries as of today. The climate change issue is a global issue. It's not just a European or American issue. It is a global issue. So everybody has to contribute. And Chinese, the Indians, they are having quite a few coal-fired power stations, you are saying, and making their part of the emissions, and they have to take their part of the burden. On the other hand, the CO2 emission per capita in India and China is far, far below what it is in Europe or indeed in the US. So there has to be some kind of a trade-off, an agreement here. But what we do need a global framework for emitting CO2 if this is going to work. Could start on a regional basis, Europe, US, Australia maybe, but it has to develop. Because if we just have it in Europe, then the steelworks, for instance, are moving just from France to China. It doesn't help the climate. It's mainly a tool to bridge the gap between the current fossil fuels and the future renewables and other kind of energy sources. But time span depends on development of renewables and other sources, and also the use of fossil fuels. We have big countries today, like China again, like the US, with huge sources of coal and so on, which I don't think we can expect them to leave in the ground. So I think it will be a tool for quite a few years to come.